All right, let's go ahead and get started. So I'm going to go ahead and record our session as well so I can provide this to the online class also. But this, I wanted to start off with, let's just take a look at the study guide for chapter five. So we'll know those items that we should pay closer attention to during the lecture. So for chapter five, our study guide, we're going to be talking about loops. And some things you should really pay attention to is the core loop ideas, i.e., what does every loop need? There's three steps in every loop. You got to initialize, test, and update. Also, understand what while loops are, for loop, do while loop, and we'll actually cover up to this number one, number two today. We'll also cover item number six, which is what's the difference between a definite versus an if definite versus an infinite loop. We'll also talk about nested loops today, common loop mistakes to avoid, comparisons and operands. We won't cover arrays. And then also this quick self checks on the exam. So just make sure that as I go through the lecture today, you'll pick out those items and just try to commit those to memory and or go back and look at them after our lecture, just so we can do well on our exam at the end of the week. So again, welcome to Introduction to Programming. I'm Professor Jones here at Lone Star College, and we are in week six. Week six, of course, we're covering chapter five, which is all about looping, all about looping. And in week six, again, we will have our first half of our lecture today, which is Monday. And then on Wednesday, we'll have our second half. And then we'll also cover our chapter five quiz on Wednesday, which is, of course, worth up to 50 points. And then our magic number that we're trying to achieve, at least for the first half, is up to 450 points. And then the second half is 550 points. So for each exam, each assignment, it has a specific amount of points assigned to it. And those that make it to 1,000 points will actually earn up to an A in this course. Hopefully, we'll all do well. So, what is our objective? Our objective in this chapter, which you'll learn about, is the advantages of looping. And we'll cover that also in day one. And then also using a loop to control a variable, day one as well. Nested loops, avoiding common loop mistakes. And those four items are what we will cover today. The advantages of looping, a loop control variable, nested loops, and avoiding common loop mistakes. And then when we get into day two, then we'll cover these items included below. What I'll ask you guys to do after we have our lecture for today, go ahead before our next class, go ahead and review these items here that will, for day two, using the for loop, post test, characteristics, common loop applications, and just some of the similarities and difference between sections. So the lecture notes are actually included online, so you can look at those at your leisure. So first, let's talk about the advantages of looping. So one, looping makes a computer programming efficient and also worthwhile. What does that do for you? It allows you to write one set of instructions to operate on multiple sets of data. What does that do for me? Well, that is less time required for design and coding, fewer errors, and a shorter time to compile my program. And what is the definition of a loop? A loop is simply a structure that repeats actions while some condition continues to be true, while that action is actually true and or false. Actually, it will execute. So it repeats an action while some conditions continues. And here's an example. Yes, go ahead. In the program or actually pulling from an external source? That's actually a good question. So I'll show you that, Mike, later on when I'll show you an example of where the program will create a chart and it will have its columns and rows, and those are multiple sets of data. And I'll show you how that program actually will pull from from itself to write multiple sets of data. Correct. Yeah, you can also pull external data as well. So again, multiple sorts of data. So you can use internal data based on information that you input, as well as external data that may be in a text file or a database or a spreadsheet. Okay. So here's an example, a flowchart example of what looping is. We have a condition, the condition here, and as long as this condition is true, then we'll complete some action. Again, when that condition becomes false, then we execute another action. So this condition, as long as that condition is true, then we complete this action and then we loop around. If that condition is false, then it is no. What might that condition be? If one is greater than zero, then yes, that condition is true. Then we loop around and continue that condition. If we were incrementing that value by one, then after we make that first iteration, then the new value is two, and it is also greater than zero. So this would be an example of an infinite loop if we just keep incrementing that value. Now, if we decrement that value by one, then after we do the first iteration, then in fact it is actually less than zero, or is actually equal to zero. So we have to do that loop twice. So we have two alternatives. We have a selection where condition yes, then we complete this action, go around the loop. Once that condition is false, then we exit that loop. So that's an example of a loop. An example of us doing that in real life is I was born in the 1900s. So back when we were naughty in class, sometimes we had to go up to the board and say what we would not do. So this is we getting the task done, but it's not very efficient. I will not talk in class. I will not talk in class. I will not talk in class. In the programming world, you can use a program to complete that same action, but only doing it once. So let's look at this loop here. So first we're going to start our program. We're going to declare our variables, and then we're going to go to the housekeeping function. So the housekeeping function, usually we're getting some input, some data from the user. The user may define what a variable's name is or what a variable's number is. And then we flow into this next decision that needs to be made is if we're not at an end of file, not at the end of a file, then that means that condition is yes. And so then we're going to our detail loop, execute our detail loop, and then we go back to our function and our loop. And then if we are at our end of file, then we will exit that loop and then go to end of job. So just a simple logic for a program that is in a loop. It's a simple loop in that we have our housekeeping, whatever that might be, getting some variable inputs from the user. User may say that the employee name is Kevin or the employee name is Leisha. And then once they input the employee name, as long as it's not the end of the file, then we go to our detail loop. And the detail loop may say, well, employee named Kevin, how many hours did Kevin work? Did he work 40 hours or 50 hours? If he worked 40 hours, then his pay is equal to X. If he worked over that, then his pay is equal to Y. And then we will determine when we go back through our loop, we will determine if we are at the end of the file. If we're at the end of the file, then we go execute no and then end job. So let's look at this while condition. While condition and loop. This is pretty simple in that we have while a condition is true, then we will execute some statement as long as that condition is true. When that condition becomes false, then we end while. So we always start our while loop with a while, and then we always end our while loop. And if you notice, we've got an indentation here for our statements. It allows the program to read that information. And you've got to be cognizant of the indentions. Now, our IDEs will do that for us, but if when we're writing pseudocode kind of by ourselves with text file, then we would have to indent that ourselves. So again, the note I'm trying to make here, or make you pay attention to, is that this particular loop, this while loop, which means that we're going to start our while loop here, and then we're going to this statement execute as long as this condition is true. When that condition is not true, then we exit the file. We end while.
I notice as all this pseudocode is written, it always seems like it's indented three spaces. Is that
Yeah, it could be three, or typically you would do a tab on your computer on your keyboard, and it'll indent three spaces for you automatically. But as your Mike, as your programs get longer, and if you have once you start having nested loops,
yeah,
you
it
got to keep
stacks further and further?
exactly you stack. But then with the beauty of that, it allows you to read the program better. Us, we can look at it visually and say, oh, okay, so here is a loop within inside of a loop, which means that it's a nested loop. Okay, using a loop to control a variable. So as long as the condition remains true, the statement in a while loop's body executes. We can also control the number of repetitions and how we do that. So we could say if when x is less than 4, then execute this statement. And then if we were in a loop, then as long as x is less than 4, it's going to continue to return. So we might be decrementing that variable by 1. So we would actually go through that loop 4 times. So a control loop is the number of repetitions. A loop control variable is initialized before entering the loop. So before we enter the loop, we may say x is equal to 4. Go ahead. Which one? This one, the while. So this is a example of a while loop, and we're just saying that in this particular loop, so we're setting a condition. So while this condition is true, i.e., this statement, it's going to execute this statement as long as this is true. That could be anything from is oh, 3 greater than 2. So long as 3 is greater than 2, we'll execute this condition. And then we may have another statement below here that says decrement whatever the value is by 1. And then once we get to a point where the value is less than 2 or not equal to true, then we exit the statement, if that makes sense. So as long as the condition is true, as long as my name is Kevin, let's execute this. We'll call me Kevin. If I go down to the courthouse and change my name to Robert, then that condition is no longer true because I'm no longer Kevin. Now I'm Robert. Then we exit. Otherwise, we stay in this loop. We stay in the loop until that condition becomes false. Does that make sense, Lisa? So in order to control the number of repetitions, so if we want to control the number of times that we execute a loop, we can actually set a specific number, specific number, like in this example where we say x is equal to 4. And then every time we execute that loop, we may decrement x by 1. So if we decrement x by 1, that means we will actually execute that loop 4 times because then the value becomes false and then we exit that loop. So the body of the loop must be altered for the loop to control the variable. Let me get this, clear this off just a little bit. All right. So the repetitions is controlled by a counter. We create that counter, and that counter is used to create a definite counter control loop. Or a sentinel value is used to create an indefinite loop. What is a sentinel value? That's a value that we declare. I may ask for an input for the user. How many times do you want to execute this loop? You may enter 5. You enter 5, and then now that value of the loop counter is equal to 5. then we'll decrement that number every time we execute that loop. So when it is less than 5 or 0, then we actually have set the value so that we'll exit that loop. So definite loop, pretty sure this is on the tip. It executes a predetermined number of times. So a definite loop executes a predetermined number of times. A counter control loop or counted loop is a program continues loop repetitions and numbers that. And then the loop control variable is altered by incrementing or decrementing, which means increasing, which is plus plus, or decreasing, minus minus. And then the counter is any numeric variable that counts the numbers of times the event has occurred, usually starts with 0. So let's use a definite loop with this counter. So first, let's start our program. We start our program and we declare our number count is equal to 0. This is step 1. We declare our number count is equal to 0. Now, count, as long as count is less than 4, then that sets this condition to be true, which means yes. If the count is, once our count is not less than 4, then it is no, and then we exit that. So we're actually testing that variable here. So we set our count is a number, it's equal to 0. And then the count, as long as the count is less than 4, then the condition is true. Once it is not, then it is no. So since it is still less than 4, we go here, we output hello. Once we output hello, then we set count is equal to count plus 1. So we're incrementing that count number. Remember that our condition is true as long as count is less than 4. So how many times would we execute this loop? 4 times, right? Because we start with count is equal to 0, and then as long our condition is, as long as count is less than 4, the condition is true. So it's yes. We'll output hello, and then we will increment the count to 1. We'll go back. Now our count may be 2. Is count still less than 4? Yes. So then let's output hello. So what do we think this program will do? It's going to,
It's going to increment it to forward and then
but what is it doing before it increments? Huh? It's counting, but what is it doing before it counts? Huh? If I outputs hello. So how many times is it going to output hello? 4, right. So hello, increment. Loop, hello, increment. Loop, hello, increment. Loop, hello, increment. Nope. Well, now it's greater than 4. So then I exit. So it's going to print it 4 times. So that's the example of instead of going to the board and writing, I will not talk in class, I will not talk in class, I will not talk in class. We have set our count. As long as count is less than 4, it meets the condition, we'll print hello. Once count is not less than 4, then we will exit. Okay. So that's an example of a loop as a counter. And again, you'll see in the example here, our loop control is initialized. We set it as 0, and then we are incrementing it 1 every time we follow this loop. And we're going to execute this loop as long as the count is less than 4. So once we've printed hello and then incremented count by 1 4 times, then and only then is the answer false, and then we go to goodbye and stop. So this is an example of a simple loop.
we're telling the program after hello is output, the count increases
By
by
1.
1.
Correct. Correct. And that's us telling the program when we wanted to execute. So we started our loop and we have a way to exit the loop. Okay. So this is an example of a Definite loop or defined loop. Defined loop. That's on your test. And in this example, what I'm trying to show you, I'm pretending I'm a computer. So we start off with our count, our number count is equal to 0. So we have a count chart, count column here. We also have an evaluation column here, and then an output column here, and then a count. So if we start our program, our line 3, we start off with our count is equal to 0. Okay. So while count is less than 4, is that true? Yes. Yeah, it is true. So what are we going to do? We're going to print hello. Okay. And then we increase our count by 1. All right. So then we go back because we're in this particular loop. And as long as the condition while our count is less than 4, we're going to print hello and then increment count. So then our next step is count less than 4. Yes, it is. So it is still true. So we print hello again. We increment. Is it less than 4? Yes, it's still true. We print hello. Increment. Is it still less than 4? Yes, it's true. So we print hello and then we increment. Now, is it less than 4? No. So it's false. And then we go to goodbye. Okay. So that is an example of a loop. This is the pseudocode version of the flowchart version we example here. Make sense? Okay. So that's an example of a definite loop, a definite loop. Now, let's look at an example of an indefinite loop. Indefinite loop with a sentinel value. And the sentinel value is one that we will declare. So we'll ask our user, so what is the value? So what is an indefinite loop? It's performed a different number of times each time the program executes. The user decides how many times the loop executes. So let's take a look at this example here. So first we declare our values, and then we ask, do you want to continue? Yes or no? And then input should continue. Okay. So then once we input our should continue yes or no, so if it's equal to Y, what is our condition? If it's equal to Y, then it's yes. Then we go to hello. We output hello, and then we output do you want to continue yes or no? And then we indicate whether or not we want to enter yes or no. If we enter yes, we go back through that cycle again. Then it outputs hello. Do you want to continue yes or no? And then the input should continue. And then as long as we continue to enter Y, it stays in this loop, this indefinite loop, until we enter no. As soon as we enter no, then we output goodbye and the program stops. Okay. So we've just covered 2 examples of loops. One is a definite loop with a counter. That's a definite loop with a counter. And then now we have an example of an indefinite loop with a sentinel value, which means that we determine when we continue that loop or whether we exit that loop. Okay. And here's an example of this from a command prompt where it looks for a command prompt. And then here is a GUI version. So this is GUI, graphical user interface, which we're accustomed to. And this is a command prompt. Okay. So that program is asking us, hey, do you want to continue? Yes or no? We type Y, it continues. It prints hello, and it does it again. Do you want to continue? So it's 1, 2, do you want to continue? Yes or no? User input, yes. So we're going to do it again. Do you want to continue? User input, yes. We'll do it again. Do you want to continue? User type no. Then we exit, and that's goodbye. Okay. So that's an example of an indefinite loop. Indefinite loop. And that was the command line version. And this would be the GUI version. So person would hit yes, hello, yes, hello, yes, hello, no, goodbye. Okay. Or yes, 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 no, exit. Okay. So definite loop and indefinite loop. So three steps should occur in every properly functioning loop. You should provide a starting value, okay, of the variable that will control the loop. Next, you test the loop to control to control variable to determine whether the loop body executes. And then lastly, alter the loop control variable within the loop. This is on your quiz as well. So understanding the loop. So these three steps must occur in every properly functioning loop. Now, you can create an improperly functioning loop by taking one of these steps out, but then you'll have a indefinite loop that never executes. It either never executes or never ends. Okay. So let's take a look at this flowchart program. As always, we start our program, then we have our declarations. We have someone tell me what type of variable is name. What type of variable is name? String. Excellent, excellent. What type of variable is deduct? Number. All right. Now, what is the value we set for rate? 2.5. Well, or 0.25, correct. Not necessarily 25 cent, Mike, yeah, but I know what you meant. I know what you, but it is 0.25. Now, what do we say? What is report heading? What's our report heading? If I wanted to print report heading, what would it print?
Payroll report.
Payroll report, correct. If I wanted to print column heading, what would it print? Name gross, correct. All right, so that's just our declarations where we declare our values. If we don't declare a value for a variable, what does the program print?
Garbage.
Garbage, correct. It is garbage, which is a bunch of characters and stuff that nobody even knows what it is. It's ampersand signs, number signs, minus signs, all kind of crazy stuff. So if we do not declare a variable, if we not give it a definition, then the program doesn't know what it is. So it's just going to give you output garbage. Okay, next we go to our housekeeping function here. And then in housekeeping, we're going to output and or print report heading. So if we print report heading, it's going to say payroll report. If we output column heading, then it's going to print name gross. And then what we're doing is we're asking it to input the name, input the name, which if it asks us to input the name, question for anyone, if I entered the name as, let's say Kevin in binary was in fact actually equal to 2655, what would happen?
It, it wouldn't execute because
Why not?
it's been declared as a string and not enough.
Yes, correct. Outstanding. That's what I just wanted you to. I wanted you to make sure you still recognize that. Okay, so now we've done with our housekeeping, and then we're looking for what is name equal to. So what is name equal to? So in this case, so is name greater than or less than or greater than or less than or and or equal to quit, which in this case, quit is XXX. So if I ask you for your name and you typed in Kevin, what happens? It continues on with the program. If you typed XXX, what happens? It quits the program. Correct. It quits the program. And how do we know that? Because it's looking for this value of name, whether the value is greater than or less than quit. If we type in this variable XXX, it says quit. Otherwise, we give it a name. And then if we give it a name, then it goes to the detail loop. So detail loop, then it input gross, deducts gross, deduct equals gross times rate, net equals gross equals deduct minus deduction, output name, gross, deduct, net, input name. So it basically tells this program is outputting what this person makes, what their gross is, what their net is, and then what their final payroll is. Does that make sense? Okay. So hopefully these are making more sense to you where you can look at them and see what the program is doing. We know we've got an action here. We know we've got some function here or some loop. And then if you see, if it looks like this and it's repeating itself, that's our loop. These are different functions. This is housekeeping. So housekeeping is here. We would execute that. Once we're finished executing housekeeping, then we look for this variable name is name less than or greater than quit. If it's anything other than quit, which is the XXX, then we go to the detail loop. So if I typed in Kevin, we go to the detail loop. If I type in XXX, then we go to no and end the job. Go ahead, Mike.
At the end of this detail loop in this example, are we inputting a new name in order to kick it back over?
Yes, exactly. Yeah, exactly. So anything other than XXX, anything other than XXX, send us back around to the loop. Because basically you said if you typed in dog, well, that's the computer says, okay, well, that's the person's name is dog. And then it assigns the variable name, the string becomes dog. Doesn't matter what you type in, as long as it's not 2, 3, 5, 6, 7, as long as it's not a number.
But our intention would be after all that's tallied, or inputting if I was using this program, I'm inputting a new name, so
Right,
it kicks it back around
right.
to start the loop.
Correct, correct. All right. Now let's talk about nested loops. What do we think a nested loop is? A nested loop is going to be a loop inside of a loop. We're going to nest a loop inside of a loop. So a nested loop is needed when values of two or more variables repeat to produce every combination of variables. So what's a nested loop? It's a loop within a loop. There is a outer loop and then an inner loop. So the same example that we had, that loop, we could actually put a loop inside of that loop. So not only am I looking for name, I also need you to give me a number, an age for that name. So we're going to assign that variable name a name, and then we also need to assign that variable maybe an age or something like that. So that's a loop within a loop. And until you enter a name, that I determine my variable to be either a string or a number, I'm not going to get out of that loop until you give me the variable that I'm looking for. Okay, so this is the example I was telling you about earlier, Mike, to understand pulling data from multiple sets or multiple locations. Let's just kind of diagnose this here. So,
This was a little confusing when I was reading it over the weekend. I was like,
yeah. So what we have is we've got a header here. And we've got part 1, 2, 3, 4, 5. But then within each part, we have 3 lines. Okay. So again, we repeat the same thing. Name, header, name, part 1, 2, 3, 4, 5, 1, 2, 3. Makeup quiz, part 1, 2, 3, 4, 5, and then 3 inside. What you have to start doing, and what you guys are actually doing now, is starting to recognize patterns. When you see those patterns, it no longer looks like Greek to you. It starts to make sense. All right. So let's talk about how we got to this. So, of course, we start here. We start our program. and then we're declaring our variables. We make some declarations. So quiz name is what? What type of variable is quiz name? String, correct. So is that 1, 2, 3, 4, 5, 6, 7, 8? No. It's going to have to be a letters. Chapter 1 quiz. So this is our quiz name, okay? This is our quiz name. This is our quiz name. Let me draw that on here so it makes sense. So quiz name, let me change that color to blue. Quiz name is here, here, and here. Then we have part counter, part counter. Part counter is here. Part, 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 such and so forth. And for the exact same for these guys. Part and part. So that's our part counter. Then we have our question counter. Question one, question 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Then we declare string quit. String quit is equal again to ZZZ. All right. Go ahead, Lisa. Uh, so let's look. Let's answer that question. No, because this is actually going to be something that we increment. So this is going to be one of our counters. So we're declaring this as a counter, not necessarily what's written here. So we're saying that parts is equal to 5. Parts equal to 5, which means that we're going to print this 1, 2, 3, 4, 5 times. Questions equals to 3. 1, 2, 3. So we're going to print questions 3 times. Then we're going to print our label string. We can do an infinite number of quiz names, but we're going to limit our parts to 5 and limit our questions to 3. 1, 2, 3. Okay. Yes.
Is the word parsing questions like an actual like command, like a value?
No, you could be. It could be whatever you want it to be. So that's something that we declare, which is why when we talked earlier, you need to name your strings something that makes sense. Like it wouldn't make sense to this says part and name this Volvo. You know, if you wrote the program and then Mike's got to come back and clean it up, he's like, well, why did he say Volvo? That doesn't make sense. So you got to use names that actually make sense that or relate to. Okay. All right. So we declare our variables, then we go to housekeeping. And housekeeping is what? What does it say? It says it outputs inner quiz name or quit to quit. Okay, so that's what's going to show on the screen. And then it's asking us to input our quiz name. Input our quiz name. First one might be chapter 1 quiz, but you could say whatever. You could say chapter 8 quiz, chapter 9 quiz, psychology quiz. It's whatever you input, that's what it will actually output and then return. So that's our housekeeping item. Then it's checking to see is our quiz name. What is our quiz name? If our quiz name is less than or equal to anything other than quit, which in this example, quit is equal to ZZZ, it's going to go to our detail loop. Okay. Once it goes to our detail loop, then it starts to print. We'll see in the next example where it starts to print this information out. And then once that's done, it's the end of job. All right. Yeah, you have to type in ZZZ to quit because we're checking for this. This is our we're checking for what is quiz name. If quiz name is if it's less than or equal to quit, but in our we define quit as ZZZ, and if it is greater than, less than, or if it's equal to quit to ZZZ, then we end. If you put in a test name, doesn't matter. You can say Lisa's quiz, Kevin's quiz, whatever's quiz, it's going to start printing that document. How do we know? Because this, where's our label part? Question counter, part label, right? Part label, and then our string line, okay? And then we're declaring what our quiz name is. This is our quiz name. So quiz name, and then it does the part, and then counter, part counter, part counter.
We don't declare some value for quit.
No, well, we determined what quit was. You declared quit is,
Just
then it's an infinite loop that never stops.
program to quit.
Exactly. We never get out of the quiz, which is a bad example of writing a loop. You've got to go, you have to give it a method for stopping it. You have to tell it how to stop, or when do I want you to stop. And that stop could be some action from you, or it could be a counter. Okay. Okay, so here is an example of oh, here's an example of a nested loop. Again, we said a loop that is inside of another loop is a nested loop. Okay, so we've got our detail loop. We output our quiz name, and then our part counter. We're saying our part counter is equal to 1. Okay, and then in this, if our part counter is less than or equal to parts, then the condition is true. Then we output our part label and our part counter. Then we define, if you'll see the loop inside of a loop. So we have a loop that is here, but then you have another loop inside of that loop. That is our nested loop. What does that do? Question counter is, if question counter is less than or equal to questions, yes, then output question counter. And what we're doing, oh, go ahead, Lisa. Okay, so this is a loop here. Start with this and then here. So this is one loop. And then here is the other loop inside. So we've got a loop nested inside of another loop. Does that make sense? Kind of clear as mud. So again, our question is yes. Then we exit here. So we've got this loop, and then we've got another loop sitting inside of that loop. See, here's our other loop right here.
Would that still be considered a string, like a nested loop?
It's a nested loop. That is correct. That is a nested loop. That's right.
We're nesting
Inside
that loop inside
of
of
another loop.
because the questions are inside part.
That's correct. That's correct. This is correct. Because remember, we're creating this form. So we this is our first loop, which is the part 1, part 2, part 3, part 4, part 5. But before we get to part 2, we start that nested loop, which is the 1, 2, 3. Then once we get to the third one, then we go to part 2. But then we're also incrementing that number. Once that number gets to what? Once parts gets to what? 5. Once it gets to 5, we're done. Then I go back and ask you, what's the quiz name? You can either enter a quiz name, dog, frog, smog, whatever, eagle, or you enter ZZZ. If you enter ZZZ, bye-bye, I'm out. Okay? Again, a nested loop. So some facts about nested loops. Nested loops never overlap. An inner loop is always completely contained within an outer loop, which means it's got to be clean inside of that loop. And then an inner loop goes through all of its iterations each time its outer loop goes through just one iteration. What do I mean by that?
I was just about to ask that.
So, in the case of printing our quiz, the outer loop, this inner loop must be completed before we go back to the outer loop. Okay, I see the light bulb coming on.
Yes, sir, you flip me after that. Click.
And then the total number of iterations executed by a nested loop is the number of inner loop iterations times the number of the outer loop. So if we go back to this example, three, three questions, five parts. Three questions, five parts. One, two, three, four, five. Five questions. One, two, three. Oh, I need to be writing this on that version. So again, in that example, we have five parts, which is part one, part two, part three, part four, and part five. The part is the outer loop, and then the questions, which is three, is our inner loop. We have to finish all of our three questions before we exit out to the outer loop. Okay. All right. Now let's talk about some loop mistakes to avoid, what not to do. So, again, neglecting to initialize a loop control variable. So, if you don't declare a variable for the loop, a control variable, what it says, control variable, what happens?
It goes on forever.
Exactly. It goes on forever, and it never actually you've written a bad program, and then you'll start this program, and you'll have to reboot the computer to make it stop. Okay. Neglecting to alter the loop control variable. So what happens if we in fact create the variable, the control variable, but we never alter it? We never increment it or decrement it. Again, we're stuck in that loop again. It never ends. Using the wrong comparison to the loop control variable, you could try to use a string versus a variable. It just won't make sense. Including statements inside the loop that belong outside the loop, trying to do our part inside the nested loop. It doesn't make sense. This is what we talked about before, which is our control variable is initialized here. Very important. So we initialize our control and variable here, and then here is where we're testing that variable. What is name? Is name less than or greater than quit? If it is, then that condition is true. We execute. If it's ZZZ, then we know. And then we also have a loop control variable that is being altered. So in the case of creating our quizzes, we've got quiz, chapter one quiz, extra credit quiz, makeup quiz. So we're allowed to alter that to create our new quiz. All right. So this is the proper way. This is the proper way to do it. So if we fail to initialize a loop control variable, then we're stuck in an infinite loop. And or if we don't declare a variable, what happens, Mike? What does the computer think it is? It's garbage. It's garbage. So you won't get the,
Or it doesn't know what.
it doesn't know what it is. So it's going to give you some garbage, which means that you don't know when the program will end. In this case, if we did not, if we did not declare the value of name, It may end, but we don't know when. Because at some point in time, it may get to ZZZ, but we just don't know when. So our desired outcome is not what we intended it to do. So we may sit there for 6 weeks and it won't end. Versus us actually giving the value name. So our goal was to print 100 labels, but in fact, because we didn't execute the program properly, it print 10 million labels. Okay. So in this example, this is one of the common mistakes. I believe this is number one. Okay, so we don't, our loop control variable is not initialized. So proper way, we output our name and then we output enter name. So enter name, and then we input our name. So when we take that out, then it's confusing in that we try to do it inside, it just doesn't work. We should do that outside. The proper way is to input or declare the variable or input the name before we enter. In this example, what we did not do, we didn't alter the control loop variable. So again, we'll be stuck in an infinite loop because we didn't alter the name. We user never enters a name after the first one. So then we're executing this program and we get a name and it's just going to do the same thing over and over and over and over and over again. The inner loop executes infinitely. Third mistake, using the wrong comparison when testing loop control variables. A programmer must always use the correct comparison. Some examples of what might happen if you use the wrong comparison. You might overcharge for insurance for a customer by 1 month. You might overbook the flights, or you may dispense extra medication. So there's real world implications when we program incorrectly. Okay. So here, our comparison is incorrect because we're saying if name is greater than quit, well, is Kevin greater than Mike? We can't really compare those. There's no comparison. How do we know what is Kevin? What is Mike? Mike may be whatever. So we're using the wrong comparison. We should have made this a greater than or less than, which is anything else other than quit, to create a proper comparison. Correct. Correct. So that's anything less than or anything greater than. But if it's equal to, then it's true. Okay, including statements inside the loop that belong outside. We're trying to, in this particular example, we're trying to determine whether or not we give a price discount. And instead of us declaring that discount outside of the loop, we're doing it inside. So every single time we execute, we have to do the discount versus declaring the discount outside of the loop. All right. All right. So we will stop there. That'll be our first half. And let's just do just a quick recap of what we've discussed today. Again, our objective was to understand the advantages of looping. I think we've covered that. And then also understand using a control variable, a variable that we control that determines when we exit the loop. We've also learned what nested loops are, a loop within a loop. And then we've learned some of the common mistakes to avoid in looping as well. We know the value of a loop. It repeats actions while some condition continues to be true. And here is a example of a binary, a singular loop structure where if the is true, then we execute this. If it's false, we hear. So as long as this condition is true, we'll stick in this loop. We'll stay in this loop. And this loop is this is our loop. So as long as this condition in here is true, we'll stay in this infinite loop. Once it becomes false, then we exit. This is our condition. This is our action. As long as this condition is true, we will execute this action. No matter how many times we will execute this action. When that condition becomes false, then we exit. And here's an example of an action that is completed until we reach the end of a file. Once we reach the end of the file, then we exit the program and end of job. And here we discuss what a while is, a while loop, which is while the condition remains true, we're going to execute this statement as long as that condition is true. As soon as it becomes false, we end while. And Mike, your question was valid in that it should always have indentions. Then we understand where our loop exists. What is a control variable? A loop control variable is initialized when? Before entering the loop. And then we test it. And then we also alter it. So we initialize before entering, we test it, and then we alter it. And then we go back, rinse, repeat. So the repetitions is controlled by what? Is controlled by a counter that we altered the value to get to some specific number, whether that be a sentinel value, whether we're entering yes or no, or whether we're saying when X is less than 4, then it is false and we exit. A definite loop executes a predetermined number of times. If we want a loop to execute 5 times, X is equal to 5. As we're going through the loop, decrement X, and then when X is less than is 0 is equal to 0, then we would stop. So we can either increment, and that's often in programming language written as plus plus, and decrementing is written in minus minus. But in your higher level languages, you can some of them you can get away with just plus or minus. But in your older languages, it's plus plus or minus minus. Definite loop. Here is where we're saying if our counter is less than 4, as long as it's less than 4, then it's true. As soon as it is less than 4, then it's false. Then we exit. And here was an example of how we are printing we're printing hello, 4 times. So if our counter starts at 0, then is it less than 4? Yes. So it's true. So what are we going to do? We're going to print hello. We alter our counter. We increment it by 1. Is our counter less than 4? Yes, it's true. So then what are we going to do? Print hello. We print hello, then increment our counter. It's 2. Is 2 less than 4? Yes, it is. That means it's true. And we're going to print hello again. Increment our counter. Now our counter is 3. Is 3 less than 4? Yes, it is true. What are we going to do? Print hello. Print hello, increment our counter. And then now our counter is 4. Now our new counter value is 4. Is this less than 4? No, it's false. So then we goodbye. We exit the program. Okay. Indefinite loop with a sentinel value, which means this loop will execute an infinite amount of times until we determine the sentinel value. We determine when it exits. So we can literally hit yes, 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 yes on the keyboard, and it goes on forever. It's not until we hit the end or no that it exits this program. And here's an example of a command line and a GUI version. So as long as we hit yes, we print hello. Yes, print hello. Yes, hello. No, then it prints goodbye. In this example, as long as we hit yes, hello, hello, hello. As soon as we hit no, then it's goodbye. Okay, so again, these are the 3 steps that should occur in every properly functioning loop, which is 1, you provide a starting value. 2, you test the loop. 3, you alter the loop. Remember that, ladies and gentlemen, that will be on your exam. These are the 3 steps. Every for a proper loop, a proper functioning loop, provide a starting value, test the loop, alter the loop. Whether you're going to increment or decrement, so that you can get out of that loop. Say that again, Lisa. So it's any loop. It doesn't have to be a nested loop. It could be any loop, but you've got to alter it in order for you to be able to exit that loop at some point in time. Otherwise, if you don't alter it, it just does this. It goes round, 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 round. Because we're not altering it. We told the program to print hello, and if the value is true, it's going to print hello, print hello, print hello, print hello, because we haven't altered it. Correct. Yes. Yes. So if we tell it to do it 4 times, we're going to decrement, alter. We're altering it. We're decrementing it 1 time every time it prints hello. Okay. We talked about nested loops. A loop within inside of a loop. The outer loop contains the other loop, and the inner loop is the loop that is contained. Some facts about loops is that nested loops never overlap, and the inner loop goes through all of its iterations. Each time its outer loop goes through just 1 iteration. What does that come into play? We are executing, we are our questions, which is our inner loop. We finish our questions before we go to part. Part, questions. Part, questions. Part, questions. So that means that you can't jump around. I can't do part, then questions, part 1, questions. That's an inefficient way of writing. It's actually going to be pretty complex in writing that code that it can be done, but it's not efficient. Uh, Again, pay attention to this. Common loop mistakes: neglecting to initialize a loop control variable, neglecting to alter the loop, using the wrong comparison, and including statements inside the loop that should be outside. Yes.
Another question about the comparison.
Uh huh.
This example that don't do that we went over.
Hmm.
If you declared that you need a name. You declared that quit is ZZZ.
Mhm.
Why does name need to be compared to anything? As long as you're putting a name in, it's not going to do what it's supposed to do.
Right. So if we don't compare the name, then how do we know when name is equal to ZZZ? Then if we don't make the comparison, then it's just
And ZZZ is still considered a name,
right. Exactly.
even though we declared ZZZ as quit.
Correct. Yes. So we do, but we set ZZZ is equal to quit because that's our unique name that we want to be able to. That's our variable that we're allowing to equal to allow us to exit our loop.
If I don't compare name to quit in that instance in that condition,
Right.
then doesn't the program already know that ZZZ is quit? Wouldn't it quit?
Oh, but so it does know it's quit because you told it it's quit, but it has to compare it to as compare it to make sure it's still equal to that it's not equal to quit. So in that example, we're trying to make sure that it's not equal to quit. When it is equal to quit, then we execute some other because we got to determine whether a condition is true or false, on or off, true or false, yes or no. It's interesting because the complexity of what we do is all based on it being either true or false, either it's a zero or one. It's just logic.
Which is very not complex.
Right, exactly. Exactly the point.